Hello guys, how are we doing today? Okay, so I think we can begin now. So TGP, Tie Guy and Sai are flipping fair. So they're all flipping coins until they respectively obtain their first hit. It's a nice little problem. We'll see a couple of ways to do it. Interesting problem. And let T, G and P represent the number of flips needed for Tie Guy and Sai. So how many flips they need to obtain the first head is represented by numbers T, G and P. We have to figure out the probability that T is smaller than G is smaller than P. So the tie gets head first and then the guy and then the Sai. What is the probability of that happening? Okay, so we are interested to T will be less than G will be less than P. So there are a couple of ways to do it, more than a couple of ways. So but let's start with one. So since it's inequality, there is no equal sign. So first let's try to figure out the probability all unequal. Then we'll do this. So to get all unequal, let's figure out the probability. That is nothing but 1 minus sum of them equal. So probability sum of them equal. Okay. So for this we need this. For this we need sum equal. Okay. So at least sum equal, all unequal. So the probability of sum equal is, let's figure out first the probability that all are equal. T equals to G equals to P. At least sum equal. So this is at least sum equal. So let's figure out the probability all of them are equal. So the T gets turned in K. So suppose it is equals to K. They are all equal in K. So the probability of that happening is the T can get first head in K turns is 1 to the power K. So if he get head in the first turn, that's the probability. If he gets head in the second turn, so the first he should get tail and then he should get a head. And in 3 turns, he should get tail and then head. So in K turns, it's that. Okay. So the probability T equals to G equals to P equals to K is T is K, G is K, they are all independent. And obviously P is K. So that's the probability. And so the total probability is obviously sum. So K can be 1, they can be equal in the first time, second time, or any other time. So this is the A upon 1 minus R. A is 1 by 8. So I guess that should be 1 by 8 upon 1 minus 1 by 8. So the sum of this whole thing is coming out to be 1 by 7. Okay, so this is all three equal. Now let's figure out the probability of two of them equal. So T is equals to G and not equals to P. So let's figure out the probability of T equals to G. We'll figure out not equals to G later. So obviously T equals to G has this probability at K, and same thing, we'll integrate the K, and obviously 1 by 4 upon 1 minus 1 by 4, and that's 1 by 3. Okay, so this is T equals to G, and they should not be equals to P because we already know what to do equals to P. So what happens when they are all equal? The probability of that is 1 by 7. So T equals to G not equals to P is 1 minus 1 by 7. So that turns out to be I guess 4 by 21, right? The probability that they're equal, T is equals to G and they're not equals to P. And same thing, obviously by symmetry, T is not equals to G equals to P, and same thing, probability of G not equals to T, which is equals to P. So basically, so the probability of two unequal, exactly two equal, is 3 times 4 by 21, which is 4 by 7. So probability at least sum equal that. So now we are going back. Sum equal equals to 4 by 3. Oh, I have gone into the realm of absurdity. 4 by 3 is the probability. Obviously 4 by 7. It's okay. That's fine. 1 by 7 plus 4 by 7 plus 1 by 7. 1 by 7, all of them equal. So we subtracted it 3 times and then we added 1 time. So that's how it goes. 5 by 7. So that means probability all unequal is 1 minus 5 by 7, which is 4 by 7. And then the probability of t less than g less than p. So they're all unequal, but we can arrange them in an order. So there are 6 ways to arrange, 3 ways to select the first person and 2 ways to select the second person. So it's 4 by 7 all unequal probability divided by 1 by 6. So that is 1 by 21. So that is our nice little answer. The probability is 1 by 21. So how did we do? So they are unequal. So t is less than g is less than p. So let's figure out the probability of them being unequal. So to do that, let's figure out probability them being equal. Some of them being equal and all of them be equal. So that was 1 by 7 and 4 by 7. The probability at least some equal is 5 by 7. The probability they are unequal is 4 by 7. Okay, I did make mistakes. I'm on a fire today. So this. Okay, but I got the right answer because I knew the answer. So even though I made the calculation mistake, I got the answer. Okay, the probability of all of them are unequal is 2 by 7, and the probability that of this particular order is 1/6 of that. So that is 1 by 21. Okay, so nice little solution for our problem, and I did say we can do it another way. So let's try that. Okay, so the chance, we'll do some things. So we want t less than g less than p. Okay, so let's say that t less than g less than p. So the all the different ways that we can have number t is half to the power t, and so a particular set of TGP is this half to the power g and half to the power p. Now we are fine with t having any value 1 to infinite, right? And we are fine with g having any value as long as it's greater than t, and we are fine with p having any value as long as it is greater than g. So this is the probability of TGP, probability of a particular TGP. So we have to sum all that. The probability of t greater than g greater than p will just sum. So t can start with 1 and it can have any value, and g can start with t plus 1 and can have any value. I don't really care. And p can start with g plus 1. It can have any value. I don't really care. So let's forget about these two terms. So let's do the first, this sum, 1 by 2 to the power p. And I'm just putting them here because they are not concerned. They do not feature inside this. Okay. So inside is only p. So I'll just put them here. Okay. So this thing is, so sum of, so the first term is 1 by 2 to the power p, and then p, and the p starts with g plus 1. So this is my a upon 1 minus r. So I'll just, I'm just adding to infinite. So next term only I'm just increasing the power by 1. Okay. So so 1 minus 1 by 2. So 2. This is what I'm getting. Okay, and the whole things. Okay, so I'll just delete the solution, delete this part, and I will be a little smart, but then I can't verify my steps. So yeah, that's a dilemma. G plus 1 to infinite. So I'm claiming that this is true. A upon 1 minus r, 1 minus half. Okay, so into, let's call this k. So I'll put k here, and I'll put, so this inner sum is equals to this. So the next sum is, so I'll forget about this, and let's just do the second term. So this is K1, this is K2. So K1, K2. So let's forget about K1 and let's sum K2. So G equals to T plus 1 to infinite as long as it is greater than T. And the first term is half into G, and the second term is also half into G. Okay, because uh, 1 by 2 G into 1 by 2 into 2. Okay, so this is fine. So we are done. So this is 1 by 4 into G, right? So this whole thing I will just write 1 by 4G. Okay, so this is again A, what is A? 1 by 4G upon 1 minus R, and the R is basically, again I am multiplying with 4, so 1 minus 1 by 4. Okay, so I have to be a little more careful. 3. It is this peeling onion thing is not really easy. It's a hard solution, but yes, the steps are less. In the previous part there were lots of steps, but it was particularly easy. Here okay, so let's pray and move forward. So now we have half. Okay, so the G starts with T plus 1. So the first term is T plus 1. Okay, so here the first term is half to the power T into 4 by 3, so into 1 by 4 to the power T into 1 by 3. I do hope. I already know the answer, so let's see. So and then we sum it, so it is 1 by 3 sum of 1 by 8 to the power T. So that's 1 by 3 into 1 by 8 upon 7 by 8. So I'm getting 1 by 21. Okay, so yes, the answer is matching the previous option. So here what did we do? So we said, okay, I don't know where the K start, but K can have any value as long as it starts with 1, and then it can have any. And I'm fine with G having any value as long as it's greater than T. So I'll sum all of. So I'm basically summing all the cases. So I'm summing 1, 2, 3, I'm summing 1, 3, 4, I'm summing 1, 4, 7, all those things. And P can have any value as long as it's more than G. So I added P, all the probabilities of P in terms of G. Then I added all the probability of G in terms of T, and then I added all the probability of T, where T goes from 1 to infinite, and I ended up with 1 by 21. Or you can do this. This is also fun, where you figure out first probability all unequal, then at least some equal, and 2 equal, all of them equal, and then we figure out the probability of at least some equal, and then you have all unequal, and then 1/6 is the answer. Both are fun, so I do hope you like this. I did not prepare a code for this, so let me see if I can do that immediately. Okay, so I do have the code ready for this. So I said I don't have the code ready, and then immediately in a second I have the code ready due to the power of AI. Okay, so I asked AI to TGPR flipping fair coins till they get ahead 5% of time when T is less than G is less than T using 100,000 iterations. Okay, so you flip the coins, you do the iteration, so 100,000. So I did a million iteration. Let's do 10 million. And 1 million is good enough. Let's do 10 million anyway. Okay, so while it runs, let's do the code. Okay, so T less than G less than P. So you get their coin flips and total coin flips and how many times it happens. So we do the iteration till we have to break. Okay, and the percentage is 15 seconds, 10 million flips. That's a lot of it. It's 4.77%. That's not bad. And let's see, the answer that we got was 1 by 21 through 2 different methods. So let's see what it is. 1 by 27 is 4.76. So that's good. Let's do 100,000 times. So let's see if we get 4.76. We got 4.76. Okay, we got 4.70 and 4.75 and 4.81. So it is not really a very sharp graph. So let's do 1 million times, and it is 4.76, coming out a lot, and it can take 10 seconds. So let's see what happens when you do it 10 million times. So I do hope you understood the code, and what did we do here? So all unequal, at least some equal, all three equal, two equal, at least some equal, all unequal, and then 1/6 of that. Or we just counted t can go from 1 to infinity, g can go anything as long as it's more than t, and p can go anything g. And then we did the 3 geometric sum, and now we are here. And then again we ran the code, and in the code we got heads. Till we get heads, we flipped the coins, we ran the iteration 10 million times, and we counted out of those how many in the t is less than g is less than p, and we got 4.7. So I do hope you learned everything here. So keep learning, keep being awesome.